All right. In this example, this is very similar to problem 7 through 12 on your worksheet. It's also almost identical to a problem that I might ask you for the second question on your quiz tomorrow. This one has two elements. The first element is what's written on top of the type directions, and that's asking you to label the vertex, axis of symmetry, max or min, y-intercept, and x-intercepts on the graph. Okay, so looking at the graph, I want you to show me where the vertex is, and we can do that by observing where the graph is changing direction. And I can see that happening right here where I've placed the dot. I'm also going to draw an arrow to it, and I'm going to identify it as the vertex. Okay. Apart from that, I also want you to draw in, using a dashed line, where the axis of symmetry is. And remember, the axis of symmetry is the vertical line that goes through that vertex. Okay, and I'm going to label this AOS for short, axis of symmetry. Next, I want you to tell me where the max or the min is. Remember, the parabola is either going to have a max or a minimum. It's not going to have both. And we can see from this parabola, I have a low point where that vertex is. It's at the bottom of a valley. That tells me that this graph has a minimum. And that minimum is also where the vertex lives. So drawing an arrow to where it is and labeling it as a minimum. Okay. If your parabola opens up in the other direction, if it looks something like this, you would have a maximum value at the high point, the top of the mountain. Okay, next I want you to indicate where the y-intercept is. And we can see that y-intercept is happening where the parabola is crossing that vertical y-axis. Okay, where I just placed that next dot, labeling that one as y. You can abbreviate this as int. I know what that means, y-int, short for y-intercept. And then the last element is the x-intercepts. Okay, so that's going to be where the graph is crossing the horizontal x-axis. In this case, we have two. We have one over here on the far right, labeling it as x-int. And we also have one over here on the far left, which I will also label x-int. Remember, for the x-intercepts, it's only have one, and it's also possible to have none. Okay, but in this case, we have two. That's the labeling part of this problem. The second part is the typed instructions. This one is the one where I want you to create a list next to the graph for each item. So I can see here, the first thing is to identify the vertex. So I'm going to write vertex. If you write the letter V, I would understand what that means. Axis of symmetry, which again, I'm going to abbreviate AOS. Direction of opening, which I'm just going to abbreviate as direction, or DIR. Max or min. We've already established that this one is a min value, so I'm going to write min only, not max. I am looking for you to determine which one it has, so I am looking for you to write the correct word. Next one is the y-intercept, x-intercept, and then the last two are domain and range. If you want to just write D, short for domain, that's fine, and R, short for range, that's fine as well. Now, we're going to look at the graph and we're going to figure out what all these values are. Starting with the vertex. I can see where the vertex is because we've already labeled it, and the ordered pair where that vertex lives is at 2, -6. 2, -6. The x value is 2, the y value is -6. Axis of symmetry. Again, axis of symmetry is a vertical line. So vertical lines always start as x equals something. And it's going to be the x value where that line goes through. And since this goes through the vertex, it's going to have the same value as the x value in the vertex. It goes through x equals 2. I am specifically looking for you to say x equals something. If you just write 2, you will not get full credit. This is an equation of a line, not a value. So you must write x equals 2. Direction. This is about looking at which direction the arrows are pointing as the graph is opening. And for this one, we can see that the arrows are pointing upwards as the graph is going out. So for this one, the direction of opening would be up. Okay, the other option is that the direction of opening is going down if the arrows are pointing down. Okay, for the minimum is going to be the y value at the lowest point. And we've already labeled where that y value is and drawn an arrow to it. But in case where you're unsure, the minimum or maximum value, whichever it is always going to be the same as the y value in the vertex. So if we know the vertex, we know what that minimum or maximum value is. So in this case, our minimum is -6. Okay, again, minimum is not an ordered pair. It's not a point, it's a value. Okay, my minimum value is -6. All right, y-intercept next. That's where that graph is crossing that y-axis. We're looking for the number, the y value number, where it's crossing. And I can see that I drew my point right between -4 and -6. So I'm going to say the y-intercept is -5. Okay, you can also write the y-intercept as an ordered pair, 0, -5, and I would be okay with that. All right, x-intercepts. Since we labeled 2 on the graph, we should have 2 responses to this question. And we're looking for the x values where we're crossing. So on the left side of the graph in the negative numbers, I can see we've graphed and crossed at -3. And we've also crossed on the positive side at 7. Again, x-intercepts can be points as well. So if you wanted to express them as a point, you could say the point -3, 0 and 7, 0. I would accept both of those as well. All right, the last 2 questions. Domain. Domain, domain, domain. No matter what happens in a quadratic, the domain is always the same, no matter if it opens up, opens down, crosses the y-axis, doesn't cross the y-axis. The domain is always, always, always going to be all real numbers. We talked about this in class. Every number can be multiplied by itself. So there's no restrictions to the values that we can use for x when we're evaluating our equation. Range, on the other hand, is not all real numbers. Range represents all the possible y values. And in this case, because we have a minimum or a maximum value, we have a break in our y values. So when we write the range, we're going to write squiggle braces, y, and then we're going to draw a vertical line, and then we're going to write an inequality statement that represents where all the y values are. So in this case, when we write that inequality statement, it's always going to be compared to the minimum or the maximum value. So in this case, since we know that minimum is -6, that's the lowest point where the vertex is, y is going to be compared to -6, and we're going to close the squiggle braces there. When we want to figure out which inequality symbol to use, we need to look at the graph and ask ourselves, which side of that -6 does the graph live on? And in our example, the graph lives above the minimum value. So therefore, all the y values are going to be bigger than -6 because all the numbers above -6 on the graph are going to be bigger or equal to -6. Make sure that you include the line underneath that greater than symbol. Okay, if this was a maximum problem where the graph is opening down, then we would say that y is less than that max value. Okay, so this one is a perfect example of what I'm looking for the second question on the quiz tomorrow, and also problem 7 through 12 on the back. If you don't have enough room on your paper, just write it on a separate sheet of paper and we can staple it in class before you turn it in. I hope this helps you guys answer your questions. Good luck. Have a good night.